Hi there! Ever wondered why oil and water appear as droplets? Well, let's find out why. This is because of something we know as surface tension. It is a property in which surface molecules of a liquid try to hold the liquid together to acquire a minimum surface area. So what happens inside a liquid or oil droplet? Now imagine that these are molecules inside water and the red arrows represent the force. Since these two forces are equal, it gets neutralized. So the net force is zero. So what happens on the surface then? Well, the molecules on the surface not only attracted inwards and sideways. This inwards force results in the contraction of the surface molecule to a sphere that achieves the minimum surface area, which is sphere. So what are the examples? First, walking on water. Second, clinical test for jaundice. From the experiment, it is seen that the coil could hold more droplets of water than oil. Thus, it states that water has a stronger surface tension than oil. This is because of polarity. Water molecules are polar and contain hydrogen bonds. Thus, their surface tension increases. Oil, however, is non-polar. They do not have hydrogen bonds, but they do have weak intermolecular bonds. Therefore, surface tension decreases. So, what are the challenges and ways we can modify the surface tension of water? The challenge is high temperature, which is also a way to modify the surface tension of water by lowering it. As seen from the graph, the surface tension decreases with increasing temperature. So, why is surface tension so important in many industries, such as food industry? Surface tension, food coatings cannot work. Food coatings can be found in seasoned potato chips and nuggets. Second, latte art is also related to surface tension in forming different beautiful designs. Next, the formation of tears of wine is also due to surface tension. Lastly, Teflon-coated pen is one of the applications of surface tension too. For your information, surface tension is involved in what you are doing now, I mean breathing. The presence of surfactants in our lungs reduces the surface tension between moist lung surfaces in an air environment. With a reduction in surface tension within the lungs, less pressure is needed to inflate the lungs. So, have you ever mixed oil and water together? You will notice that they don't mix together. Instead, they form two separate layers. Here's why. The surface tension of oil and water are different. due to the bonding. Oil molecules have weaker bonds, thus it has lower surface tension compared to water, which has higher surface tension due to the hydrogen bonds. When oil is mixed with water, they group together instead. Surface tension needs to be lowered for them to mix. If not, smaller droplets will gather into one layer. There are many non-visible food ingredients, thus they form separate phases within the food. These particles are very small and are not visible, however, they will appear homogeneous. This is what we know as a dispersed system. In the dispersed system, at least two phases will exist: dispersed phase and continuous phase. In the dispersed system, both dispersed and continuous phase can exist in solid, liquid, and gas form. When both dispersed and continuous phase are liquid, they form an emulsion. These are temporarily stable mixtures and are usually stabilized by emulsifying agent. There are two common types of emulsion: simple emulsion and multiple emulsion. There are a few challenges we have to face with emulsions, as they affect their stability. First, phase inversion. Internal phase becomes external phase. Second, flocculation. Droplets stick together. Third, creaming. The less dense phase rises to the top. Fourth, sedimentation. Falling of droplets due to difference in densities. Next, condensers. Emulsified droplets merge together to form larger droplets. Lastly, Oswald ripening. The smaller droplet gets bigger. Since oil and water are non-measurable liquids, why do some fluids appear homogeneous? When two non-measurable liquids are in contact to each other, they try to minimize the interfacial tension. Surfactants can maintain the stability. What are surfactants? They are compounds that lower the surface tension between two phases. They are amphiphilic, meaning they have a hydrophobic tail and a hydrophilic head. The water-loving group is attracted to water, while the water-hating group is attracted to lipids, ultimately lowering the interfacial tension, thus easier to mix. Emulsifiers are surfactants. They contain charged and uncharged head groups. Stabilizers are water-soluble polysaccharide food gums. It is mostly used in stabilizing oil in water emulsion. Larger stabilizer molecules will increase the viscosity of the emulsion. higher viscosity of continuous phase, more drag is created in dispersed phase, decreasing the particle size. Larger the molecule in continuous phase, smaller the molecules in dispersed phase, thus more stable emulsion. So, why is emulsion so important to the food industry? First, it increases product stability and obtains a tolerable shelf life level. Second, it changes crystallization of fat. Third, it modifies functional properties of food components. Fourth, it regulates food product viscosity such as fillings. Next, it improves cake volume. Furthermore, it increases fat dispersion in ice creams. Moreover, higher resistance to mixing and mechanical exploitation of dough conditioners. Lastly, it prevents separation of oil in peanut butter.